Yo, James, could you solve this for me, please? That's not how you do it, man. This is how.
For some integrals, like the integral of ln x, we must use integration by parts because other integration methods just will not work. So for this, we can use the formula up here to solve the integral I've written down here. So for this, we'll have u to be equal to ln x because of the picking method that I have written over here. You must memorize is using the acronym LIATE. The derivative of v will be 1. The derivative of u, or u dash, will be 1 over x. And the integral of v dash, or just v, will be x. So using the formula, this will thus be equal to x ln x minus the integral of 1 over x times x dx, which is then equal to x ln x minus the integral of dx, which, using the integration techniques that we have learned, is just simply x ln x minus x plus c. And there you have it, the integral of ln x. And also, do not forget the plus c. It will cost you marks.
Good job. Can you try this?
Three hours later.
Why'd you give up? Just keep doing it. Whoa, good job. I'm so proud of you, bro. Now for your final challenge. Solve this.
You can also use integration by parts for more difficult integrals, such as the integral of e to the x times sine x dx. And I'll show you how to do it. So, for this integral, we'll have u be equal to sine x, u dash can be equal to cos x, v dash will be ex, and v will also be e to the x. So, this whole thing would be equal to uv minus u1v, so that'll be e to the x sine x minus the integral of u1v, which is e to the x cos x. But over here, you might notice that we can't just integrate e to the x times cos x dx that easily. So we'll use integration by parts again. So over here, u will be equal to cos x. U dash will be negative sine x. V dash is ex, and v is ex as well. So this whole integral would thus be e to the x sine x minus, open brackets, uv minus u1v. So that's e to the x times cos x minus the integral of negative sine x times e to the x. So that'll be positive, just e to the x times sine x dx. We can then expand the brackets to get minus e to the x cos x minus the integral of e to the x sine x dx. But over here, you might notice that the integral on the left-hand side, e to the x sine x dx, and on the right-hand side are actually the same. So we can use just algebra and move the integral on the right-hand side to the left-hand side and add them together. So that would actually just give us 2 times e to the x sine x dx being equal to e to the x sine x minus e to the x cos x. And just dividing both sides by 2 to get the integral that we actually want from the start of the question, which is over here, we can just get the integral of e to the x sine x dx as being equal to e to the x sine x minus e to the x cos x divided by 2 plus c. And yes, that is how we use cyclical integration, which is a variation of integration by parts, to solve more challenging integrals like this.
So now you know integration by parts.